Hello everyone, my name is Nahapetyan, and I'm here to present our work on SMS phishing tactics and infrastructure, collaborative work between NC State University and PayPal that was published at IEEE SMP 2024. So what is phishing? Phishing is this form of a social engineering attack where a malicious actor will pose as a trustworthy colleague or an organization in order to lure you into providing sensitive information or access to your network. APWG, the Advanced Phishing Workgroup, has cited nothing but an increase in the number of phishing attacks observed for the last 4 years. Now, SMS phishing is unique because, on one hand, prior work has shown that it is highly effective in control simulations, and on the other hand, it is a telco abuse phenomenon, but since they leverage web resources in order to lure you into providing personal information, we can use web abuse techniques to study this telco phenomena. We can look at the registrar, the host name that they use, alongside we can pull SSL certificate information to try to estimate time of deployment for the domain. To do this kind of measurement work, we first needed a dataset of SMS phishing messages, and so to collect that we turn to public SMS gateways. These are websites where you'll have a target number at the very top and then a list of messages that are sent to this number below that. Usually these will be the last 50 messages sent to this number. However, some gateways will opt to show you historic records dating all the way back to when they first acquired the number. We crawled a total of 11 SMS gateways, collecting over 200 million messages. Out of those messages, we identified 60,000 that were phishing, which we isolated into 35,000 campaigns, which we clustered into over 600 operations. And the way these gateways make revenue is by showing you ads. And so let's look at an example phishing campaign and how it was captured using these gateway numbers. Here we have a phishing campaign documented by the bleeping computer, where you would be texted a URL to what appeared to be a Bitcoin wallet, alongside with a username and password and how many Bitcoin you had in that account. Once you sign in, the website will prompt you for a credit card or a debit card number or some kind of bank information in order to make a withdrawal out of that number of Bitcoin into your account. And we can see that these campaigns were indeed captured by these gateways. This is just part of a search page, and we can see that actually one of these numbers recorded having the same message sent to it twice within the span of the 2 weeks. So to summarize our data collection pipeline, we first crawl these gateways, collecting the to and from phone number alongside with the message body and the time. Once we have the SMS messages, we extract any URLs out using a regular expression, and we pass it over to our oracles for evaluation. For VirusTotal, in order to avoid any kind of false positives, we set a threshold of how many engines need to label the URL as a phishing URL before we mark the SMS message itself as a phishing text. Once we have the messages that we know are phishing SMS messages, we cluster them into campaigns. We don't do any kind of edit distance-based clustering, but rather we extract out URLs, phone numbers, one-time codes, and email addresses out of these messages. And if text messages are otherwise exactly the same, we collapse those into the same campaign, which replaces those things with a placeholder. Once we have these SMS campaigns, we construct a bipartite graph of the campaigns and the URLs that are used within these campaigns, and connected components of this bipartite graph is what we call an operation. For example, I have a sample operation on the screen right now. However, a campaign can have more than 2 URLs, and a URL can actually be shared by 2 or more campaigns. When it comes to individual phishing messages, we found that most URLs in the message will redirect you to a different hostname entirely than the one that was included in the message. Majority of the SSL certificates were issued for these hostnames weeks before we first encountered the URL on these gateways, and we find that the common cloud service providers for these websites were Cloudflare, AWS, and Google. Unlike other types of telco fraud, we did not observe any kind of seasonality in the traffic. We did observe that the top 5 second-level domains that we've encountered all appeared to be URL shorteners. However, only 2 of those were public URL shorteners. The rest, we were not able to identify a public interface to register a shortened URL through, and so we speculate that these are used either by the malicious actors themselves or by someone who's providing this as a service to potentially only malicious folk to use. Compared to a list of generic phishing URLs like those used in prior work, we find that SMS phishing hostnames tend to be shorter, and we actually observe an upper bound of around 40 characters for hostnames in our dataset. We find that the average character length for the campaigns themselves is about 90 characters, which leaves only 70 characters for the URL, which includes the hostname, the schema, as well as the path. And so prior work has identified that malicious actors use these gateways to bypass phone number verifications. However, we find that malicious actors may also use these gateways to test potential malicious traffic delivery routes. We find a total of 45 operations, or 161 campaigns, that have a textual pattern of route, followed by a number. This, alongside with the fact that we have 16 hostnames that have their SSL certificates issued 12 hours after we find the first message arrived to the numbers belonging to these gateways, leads us to conclude that malicious actors use these SMS gateways to test delivery infrastructure before they send out any campaigns to potential victims. On the phishing operation side of things, we find that multi-campaign operations have very similar campaigns when compared using edit distance. We find that the top entities that were mentioned in these operations are Apple, Common Bank, DHL, and then the Australian government. However, we do find that the 87% of the operations did not mention a detectable named entity. So one last thing that we looked at are avenues to deliver your malicious traffic if you don't want to turn to traditional A2P providers. So we crawled LinkedIn for advertisements for bulk SMS services, and we identified over 40,000 posts that advertise bulk SMS services. On the slides right now, I have a Telegram screenshot from a group called General Phishing, where someone links back to one of these posts on LinkedIn, and while on LinkedIn they don't spell out willingness to send out spam and malicious content, they do so on the Telegram side. And so to summarize, phishers use SMS gateways to test their SMS delivery infrastructure, which lets us study their tactics using these gateways and identify campaigns that are not yet sent to any potential victims. SMS phishing operations that we observed are short-lived, use 122 URLs, and target English speakers in the United States, UK, and Canada. And while carriers treat SMS phishing as an access control issue to bulk messaging interfaces, we find that there's an ecosystem of individuals who advertise bulk messaging services. Thank you so much for your time. I welcome you to check out the paper alongside with our data at the QR code and URL provided. Thank you to my co-authors and sponsors for this project, as well as the SMP committee for their feedback.